Okay, so here's the first problem we want to look at. Now, this is something similar to what we looked at the other day. This is one where we're given a volume and we're asked to find a missing dimension. In this case, asked to find the height. Okay? Height y. So what do we do for problems like this? How do we always approach these? Say it again. Find the slant height. Is slant height important in calculating the volume? Is it? No, it's not. Only for surface area. Okay? But what do we do? What do we do first for a problem like this? Write down the equation. Yeah. We always want to start with the formula. So the volume of a pyramid is what?
2076.
Okay, we have a number for it. You're right. What about the formula?
Like base.
Okay, base times height. Yeah, times 1/3, right? 1/3 base times height. And height's what we're looking for. The height is y in this case. That's what we're looking for. Okay, so we can calculate the base very easily. What's the base in this case? What's the shape of the base?
Square.
Square. Yeah, so it's easy. What's the base area then? Yeah, x times x. 15 times 15, or 15 squared. 225, right? So then if I plug in the stuff, I know that the volume is 2706. That equals 1/3 times 225 times h. So what do I do to get the h by itself then? Okay, I could multiply by 3. Good. Multiply both sides through by 3/1. Right, so the 3's cancel. And I'm going to get something big on this side. 8118 equals 225 times h. And now what?
Divide by
225. We got it, right? No big deal. So, on our calculators, eight one one eight divided by 225 is 36.08. Done. No big deal. Okay. Okay, next one. Find the surface area of the regular pyramid or cone. Okay, these are, they're just following a formula. Not that bad. Okay, thank you. Yeah. So what is the formula for calculating the surface area of a pyramid? What's the surface area of a pyramid? You better remember. It's on the sheet. You guys in the back okay back there?
Yeah.
Okay. Okay, one base, good. Plus, 1/2 perimeter of the base times slant height L, good. Okay, and the only hard part of this really is L. I mean, actually, not even L. L's given to us, isn't it? What's L? 30, yeah. So none of this is very hard. What we do have to see here, and for some reason this one seems to be kind of hard to see for people, what is the shape of the base of this pyramid? What kind of triangle? Equilateral. Yeah, here's the base, right? This one's dashed because it's behind the shade. But there it is. Notice that each of the sides has length x, so it's equilateral, right? Now, what's the formula for the area of an equilateral triangle? Remember? Yeah, square root 3/4 times side length squared times x squared in this case, and x is 12. So that's easy enough. You're thinking of square root of 3 times the square root of 3 divided by 2. Is that what you're thinking of?
Oh, wait, that was
Hexagon. Yep, there you go. Okay. So there's base. How do we calculate the perimeter? Perimeter is easy. How do we always calculate perimeter of the base? Add them together, yeah. And in fact, we can just multiply the number if it's a regular shape. So all the sides have the same length, like this one. We can just multiply the side length times the number of sides. So 3x in this case, right? Okay, so the perimeter then would be 3 times 12, which is 36, right? So our calculation ends up being pretty simple. Let's calculate the base first, how about? So square root of 3, get out of the radical, divided by 4 times 12 squared. There's the number for the base, right? If we want to add up the whole surface area, it's just going to be that number. Whoops, I want to go plus. So for that answer, plus 1/2 times the perimeter, which was 36, times the slant height, which they give to us as 30, right? Because that's slant height, isn't it? Distance up the middle of one of the faces of the pyramid. Okay, so times 30, and that's it. 602.35 to 2 places. Okay? Questions? Make sense? Okay. Charge on here. Okay, this guy. What about this one? So we're given a surface area, and we're supposed to find the missing dimension A. All right, so what kind of a shape is this? Okay, what kind of triangular prism? Equilateral triangular prism. How do I know that? Because of the congruence marks, right? All the sides are congruent in that triangle. So what's the surface area of a prism? Equal to. Gotta add them all. How many bases? 2 plus. Remember? Yeah, the perimeter of the base times the height, and the height is what we're looking for, right? So let's do the calculations on this. Let's find the area of the base and the perimeter of the base and all that stuff, and then we can solve for h. All right, so calculating the base, you already told me the shape of the base is, once again, it's just an equilateral triangle, right? So square root of 3 over 4 times 3 squared. Okay, that's easy enough. The perimeter of the base is just 3 times the side length 3, which is 9. That's easy enough. And they give us the surface area, right? So we can plug all this stuff into the equation. Surface area of 844 equals 2 times the base, right? Which we can calculate, plus the perimeter is 9h, right? So how about if we calculate a number for the base, put it into our calculator, and then we can do all this stuff. So square root of 3, oops, 3, divided by 4 times 3 squared is that. Small base. There's the number. So now let's just go through the process of isolating h. Now remember what we're doing. We can do this on our calculator. We've got this equation with the h on the right, correct? What we want to do on the calculator is we just want to keep tabs on what's on the left side as we push everything to the left except the h, right? And when we're all done, the h is on the right, and whatever number we're left with on the left is the value of h. Okay? So let's do that. So what's the first thing I do here to the 844 on the left side? What's the first thing I do to that 844? No. No. Subtract 2b, right? And the reason being that we've got to reverse order of operations when we're isolating something. And so the first step is always going to be the add or subtract step. You're always going to ask yourself, do I need to add or subtract something to both sides to isolate H? So yeah, in this case I do. In this case I need to subtract 2 times B. So minus 2 times, and that's our base right there, correct? All right, and that gives us that number. Okay, and we've taken care of those guys. Gone. Okay, now what? Now I can just divide by 9. Right. So divide my last answer by 9. And now the 9's gone. All I've got is my H, and that's my answer. 92.91. Okay? Make sense? All right, this one, a lot of people miss this one just because, well, I can see why. There's a couple things to do here, but I think the reason most people miss this is they forgot to put the circular base on the shape they created. Okay, now let's read this. The center of the sphere is at C, and its circumference is given to us as 5 pi. So we can use that to calculate the radius, correct? If they give us circumference, we can find r, the r that goes with that. The sphere is cut in half as shown, and the 2 hemispheres are separated. What is the surface area of one of the hemispheres? So we got 2 parts to this. This is the tricky part, I think. We've got the dome-shaped part on the top, which is really just what? What's going to be, if I calculate the surface area of one of those hemispheres, what's going to be the rounded, curved part of that surface? How do I calculate that area? Half of a sphere. Hemisphere means half sphere. So we're just going to take the area of the whole sphere, surface area, cut in 2. But what's the other part? Yeah, we've now got this circular base in here, this flat circular base that we could sit on the table, right? And we got to add that part to our total surface area. What's the area of a circle? Pi r squared. Yeah. So first let's calculate the radius, right? So we know if circumference is 2 pi r, and that equals 5 pi. How do I find r? How do I solve for r? Okay, divide both sides by 2 pi. That gives us our r. The pi's cancel on the right, and I just get 5 over 2, which is what? 2.5. Okay. So r is 2.5. And then all I've got to do to get my surface area, it's just going to be half of, so I'll multiply 0.5 times 4 pi r, which is 2.5 squared, right? 0.5 times 4 pi r squared, plus the circular base area, which is pi times my radius 2.5 squared, right? That's it. Just plug it in my calculator. 0.5 times 4 times pi times 2.5 squared. So there's the first part. Plus pi times 2.5 squared. There's the circle. There it is. 58.90. Okay, yes, sir.
Do you want to put the 4 pi r squared in parentheses?
Well, you can. It's not going to hurt anything. But because your calculator is going to follow order of operations, it doesn't really matter. I'm just multiplying. It doesn't matter if I were to remove those parentheses, if I were to do this process, I could either multiply the 4 times the pi times the r squared first and then multiply times the 0.5, or I could change the order because multiplication is commutative and associative. So it doesn't really matter. It wouldn't make it wrong. If you want to do that to see it better, go for it. It's not going to hurt anything. Okay? Okay? All right. This, to me, is the hardest problem on the whole test, right here. This is it. If you can do this one, you can do them all. Promise you. Okay, so we want to find the surface area of a cone. Probably the hardest shape to find the surface of is a cone. I mean, not a cone, excuse me, a pyramid. So you already told me that the surface of a pyramid is it's one base plus 1/2 PL. And there's the dreaded slant height, right? L is the part that we've got to calculate. The rest of that stuff is easy. What's the shape of the base? What's the shape of the base? What is it? Hexagon. Okay. We have a formula for the area of a hexagon. It's on the sheet. No big deal. The perimeter of the base, that's easy. How do I calculate the perimeter of a regular hexagon? Add them up, and even easier. How many sides are there? 6. So 6 times x, right? No big deal. The only part that's tough is L. But if we look at this closely here, now L is going to be, that's going to be the distance up the middle of one of the faces, right? Okay, what they've given us is y. They've given us an edge length. So this distance right here is y, and that's given to us as being 11, right? Now, if we pull that face off, wouldn't you agree that this is going to be a right triangle? Right? What's going to be the bottom length of that bottom leg of that right triangle if x is 4? Ah, it's going to be 2. Okay, so let's pull that triangle off and make it bigger. There's the slant height. Here's edge length 11. And here is half of x, which is 2. Now 11 is the hypotenuse, right? So what's the Pythagorean formula going to tell us about this? Okay, good. L squared plus 2 squared, those are the legs, must equal the hypotenuse squared, so 11 squared. L squared plus 2 squared equals 11 squared. So then isn't L squared just equal to 11 squared minus 2 squared? If I subtract 2 squared from both sides, right? And then L is just equal to the square root of 11 squared minus 2 squared, right? Okay, so that's L. I know or can calculate the base easily. Let's write the formula of the base up there. Anybody remember what the area of a base is, or the area of a regular hexagon is?
Square root 3 over
Okay, 3 square root 3 over 2
square.
times x squared. And x in this case is 4, right? So we'll just put in the 4. That's our base. We can calculate that. Okay? So if we go to our calculator then, we can add this whole thing up. The base is 3 times, oops, wrong, I do, quit, 3 times square root of 3 divided by 2 times 4 squared. Okay, so there it is. Base area plus 0.5 times, and we just said the perimeter is just 6 times the side length 4, right? So 6 times 4 is our perimeter, times the slant height, which we haven't calculated yet. We can do it right now, though. That's just the square root of 11 squared minus 2 squared. Okay? Gentlemen, stop talking, please. There it is, 171.37, done. Okay? Hardest one, right there, promise. Okay, this guy here, now, not hard. The hard part, I think, where people miss this one is just because they weren't sure what to do with the second part of the question. How many times more surface area? Now, think of it this way. I'm going to ask you a different question, and we'll just relate it to this one. We know Mount Everest is roughly 29,000 feet and change. Mount Hood is 11,235 or 45, something like that. 11,200 and some change. if I wanted to figure out how many times bigger, how many times taller Mount Everest is than Mount Hood, what would I do? Divide. Divide the height of Mount Everest by the height of Mount Hood, right? And if I did that, what would we get? Let's see, we said 29,000 roughly. I can't remember the exact height. Divided by 11,000, we'll just say 11,200. So it's roughly 2.59, so roughly 2.6 times taller than Mount Hood. So you'd have to stack over 2.5 Mount Hoods on top of each other to get the height of Mount Everest, right? Okay, make sense? Okay. Now, how does that relate to this problem? Well, in this problem, we're given the radius of planet X, radius of planet Y, and we're asked how many times more surface area is there on planet X than planet Y. So how would we do that?
Find the surface area.
Yeah, find the surface area of the bigger planet X and divide that by the surface area of the smaller planet Y, right? And calculating the surface areas is easy. Surface area is a simple one. What's the formula for surface area of a sphere?
4 pi times.
Yeah, 4 pi r squared, right? So then we could calculate, very simply, we could calculate the surface of each planet. Let's see, I'll go over here so I can see the numbers. So the surface area of planet X would just be 4 times pi times 6397 miles squared. I get a big answer, about 514, roughly 514 million square miles. That's big, big. Okay, and that's about, let's see, 6,000 miles. That's quite a bit bigger than Earth. Earth is about 6 million meters, so that's about roughly, let's see, that's going to be about roughly 3,600 miles, something like that. Okay, so it's quite a bit bigger than Earth. Earth would be in the middle of these two. So then the other one, 1,063, we calculate its surface area, 4 times pi times, oops, I didn't do that right. I need to do 1,063 squared, didn't I? Whoops. Let's go up and grab this. And I got to put a squared there. That's better, right? So I get about 142 million, much smaller. So then if I want to find the ratio of the two, I'm just going to take the first surface area, right there, divided by second surface area, and I get about 36.21. So quite a bit more surface on that first one. Okay? All right. We're getting there. Okay, this guy. This one looks bad, sort of, but it's really not such a big deal, we're going to find. In fact, looking at this now, I honestly think that even though pyramids and prisms might be a little harder to deal with than cones and spheres, I think that this test is actually easier than the other one. There aren't any of those really hard problems on this one like there were on the other one. So I don't know, I think these scores will be great. All right, solve for x. Round your answer to the nearest hundredth. Okay, so they give us the volume, and we're supposed to find x. Now, how would you describe x? What dimension is that of that? Well, what is the shape, by the way? Okay, hexagonal prism. Good. What is x? The height of the prism. Good. Okay, now this is a volume problem. When you see volume, you're happy. Volume problems are always going to be easier than surface area problems, every time. So, what's the volume of a prism?
Base times height.
Yeah, it's just base times height. That's it, right? So calculating the base, it's just a regular hexagon. We've already done that. Base is just then 3 times the square root of 3 over 2 times x squared. Well, in this case, y squared, right? The side length squared. So there's the base, okay? The volume is given to us. So all I have to do, what do I do to get to solve for h?
The line.
Yeah, divide the volume by the base, right? That's it. So if we calculate, let's calculate the, where am I going to do that? Over here, I guess. Calculate the base. 3 times square root of 3 divided by 2 times 12 squared. So there's the number for our base, right? And we said that height is just the volume divided by the base. Well, the volume is given to us as 3494 divided by that number. I'll just go grab the base number we calculated. There it is, 9.34, the two places, 9.34, whatever units are. Okay, that's the height. Make sense? Not so bad, huh? And, okay, this one. All right, this one, a little tricky. There's a part of this that I think is a little tricky. If we're going to, but the good news is we're adding up volumes here. Volumes aren't so bad, right? I think, did I forget a part of this? I think I did. X is, yeah, I forgot a part of this. I think X is this distance from here to there, so it's the diameter, right? If we're going to add up the volume of this whole rocket, what are the two shapes whose volumes we're going to combine?
Cylinder.
Cone and cylinder. And all we do with volumes in this case is just add them up. Very simple. But I got to calculate them first. So for both of these shapes, I'm going to need the radius, aren't I? What's the radius going to be?
Half the diameter.
Okay, half the diameter. So if the diameter is x, which is given to us, then r is going to equal half of that. So what do we get? 5.715, right? Is that right? Hold it. 5 point. Is that right? 5 point. Somebody do that with a calculator. I think that's right. 5.715, isn't it?
Yeah.
Let's see. I want to check myself and make sure. Yeah, 5.715. Okay, so there's my radius. What's the height of the cone?
Why?
I mean, excuse me, of the cylinder. Sorry. Y. Good. Okay. So then we can calculate the volume real simply. What's the volume of a cylinder? Just like a prism, it's base times height, but what's the shape of the base? Circle. So then area of a circle is just pi r squared times h. So we can calculate that. That's just pi times 5.715 squared times 42, right? Okay, and that's volume of the cylinder. Now what about the cone? Cone has the same radius. Okay, that part's good. But the height, what about the height? That's not given to us, because we need the height, don't we? The volume of a cone is 1/3 times the base, which is pi r squared, times the height. We're given slant height, right? So how do we calculate height from slant height? Pythagorean theorem. Good. So we got to make a right triangle. There it is, right? So the slant height right here is given to us as being 13. The radius is 5.715, and what we're calculating is the height, h, right? So what does the Pythagorean theorem tell us then about? Good. So what squared in this case plus what squared equals what squared? No, careful. 5.715 squared plus h squared. Okay, good. So h squared plus 5.715 squared equals 13 squared. And so if I want to solve for h squared, I'm just going to get h squared equals 13 squared minus 5.715 squared. Agreed? We agree? And then if I square root both sides, h is just the square root of that stuff, right? So that's all I need to calculate volume of the cone. I'm just going to add those two things together. So let's do that. All right, so let's do, how about if we calculate the height first, how about? So the height is going to be square root of 13 squared, we said, minus 5.715 squared. So there's the number that we have for height of the cone. Okay, so the volume of the cone then is just 1/3 times pi times r squared, so 5.715 squared, times that height that we calculated. Times that, right? So there's the number for the volume of the nose cone on the rocket. Okay? To calculate the volume of the cylinder, that's easy, right there. So pi times r squared, 5.715 squared, times the height of the cylinder we said was 42. So there's big, 4,309 point blah, blah, blah. There's our volume of the cylinder. So then to get the total volume, we just add them up, right? So that number plus that number equals that big number, 4,708 and change. Okay, but we're not done. Here's the part that I think also was a little problematic. If 52% of the spacecraft, of the space in the rocket, is needed for fuel, what volume, to the nearest hundredth, what is the volume of the portion of the rocket that's available for other stuff, other than fuel? So what's going to be the percent of the rocket available for non-fuel items? 48, right? Now, how is it that we find out, if I want to find 48% of a quantity, what do I do? Times by 0.48. Exactly. I was just doing this stuff with my daughter last night. Fifth grade daughter, we were going through some of this stuff, and that's when they're starting to talk about this. And it's been a while since but you all know that stuff, right? So this number times 0.48 gives us a smaller number, which it should. That's the amount of volume available then for cargo and people and all that stuff. So to two places, 2,260.28 cubic whatever. So I don't know what we're measuring in here, but whatever we're measuring in, we don't know. Doesn't matter. Whatever it is, that's the number. Okay? Make sense? All right, we're almost there. Two more to go, and they're quick ones. Okay, this guy here, not hard if you just got to see what's going on. Find the volume of the solid below. So please note that the interior is hollow. So this is like a vase or something, right? It's got this. It's got this solid outside, and then we've drilled out the middle. So the cone is drilled out of the middle. Inside cone is drilled out of the middle of the outside cone. It's like a snow cone cup. There it is, exactly. Okay, so we want to find the volume then. Well, how do we find the volume of this guy? Okay, but what are we going to do with the volume formula? Siobhan? Okay, you find the volume of each cone, and what do I do with them? Good. Subtract the smaller one from the bigger one, because I'm removing that much volume from the big one, right? That's it. Volumes are easy. You're either adding them or subtracting them when you're combining volumes in a shape. In this case, we're subtracting. So all we got to do, and they give us all the necessary information here. There's nothing hard about this. Well, one tricky thing they give us the outer diameter. So what would the radius be of the big cone? 7. Okay, so maybe there's one piece that we need there. So R equals 7 for the outside cone, and they give us the inside radius is 5. So then the big volume is just going to be, our formula is just 1/3 pi r squared h, right? And that would equal 1/3 times pi times 7 squared, and the height of the outer one is h2, that's 16. The small volume would equal 1/3 times pi times the small radius, which is 5 squared, times the small height is 9. Calculate them both and subtract them. That's it. All right, so let's see, what do we get here? 1/3 times pi times 7 squared times 16. There's the big volume. 1/3 times pi times 5 squared times 9 gives us the small volume. So that number minus that number, 585.38. Okay. And last one. Okay, what about this? One more of these like we did yesterday. So they're giving us the surface area of the sphere, asking us to find the circumference. So what do we have to do with the surface area?
Find the radius.
Find the radius. Find the radius and plug that into the circumference formula. No big deal. So then we know that surface area of a sphere, that's 4 pi r squared, right? So 4 pi r squared equals 16 pi. What do I do to get the r by itself?
Divided by 4 pi.
Okay, so the 4 pi cancels, the pi's cancel on the right, and I get r squared equals 4. So what's r?
2.
So r is 2. Then all I have to do is plug that into my circumference, 2 pi r. I'm just going to plug that 2 in, and what do I get?
4 pi. But don't you
Yeah.
think not pi? Yeah.
Exactly, right. So we don't want to put the pi into our calculator. We want to leave the pi in our answer. So 2 times 2 is 4 times pi. So that is our answer. And what do we put it in as 4p? Make sense?
Yeah.
Got it. That's it. All right.